All right. Now I'm going to be starting the priority scheduling. What is priority scheduling? You can literally assign priority to every process. So, as an example, the processes of the operating system would have the highest priority because if they fail, user processes might also fail, or most probably will fail. Okay, so the priority here is assigning a number that actually indicates how important a process is. Usually in operating systems, such as Linux as an example, the 1 is the highest priority, 2 second highest, 3 third highest, and so on. So the less the number is, the more important the process is, okay? The problem with priority in general, here the author is talking about this priority scheduling. In fact, any priority algorithm, any algorithm that is based on priority. So you tell me what that is. As an example, first come, first serve has no priority. Well, the priority here is the arrival, the one who arrives first. And this will never cause what we call starvation. What is starvation? Is that the process keeps waiting forever. No. For first come, first serve, the process will take its turn, and when the turn comes, eventually the process will process and leave. Something like round robin, it cannot cause starvation. It cannot cause starvation. Why? Because it's in turn, and it keeps getting quantums, and eventually it will finish execution and leave. But something like shortest job first. Okay, imagine that you have a huge process and all the other processes that keep coming are very small. This huge process might wait forever, right? Why? Because all the coming processes after it are, much smaller. So this is what we call starvation. Shortest job first can cause it. Absolutely. Who else? Shortest remaining time first could cause it. Who else? Something like EDF that I will be talking about, earliest deadline first, could cause it. And so on and so forth. Okay, so we have here starvation. Okay, it's one of the problems of the priority scheduling in general. This algorithm is priority scheduling. It assigns priority to a process. If you look at this, 1 is the highest priority, then 2, then 3, 4, and 5. So if they all are there in the exact same moment, so at time 0, all of them is there, then we're going to be executing P2 first, then P5, then P1, then P4, then, P3, then P4. Here it is. Okay, that would be the sequence of execution. So that's why, see, the very first one here, P2, executes from 0 to 1 because the burst here is 1. Who comes first? P5 with a burst of 5. So it's going to work from 1 to 6. Who follows? Now this is priority 2, right? So who follows? Priority 3, which is P1. Burst is 10. So it's going to be working from 6 to 16. Who follows? P3 with a priority of 4. Here it is. And then the last one is whatever. Okay, you can calculate now the average waiting time and everything based on that. Let's do a harder example as usual, something that explains it better. So now I'm doing with priority. By the way, priority could be preemptive or non-preemptive. The author deals with it as non-preemptive. It didn't show any sign of preemptive scheduling. All right. So let's do this problem, see how it works. Okay. You have here process, arrival, burst, priority. Okay, you have P1, you have P2, P3, P4. So the arrival here is time 3. Let's say P2 is around 3 as well. 3 as well. P3 arrives at time 5 and P4 arrives at time 7. The burst here, this is 2, this is 10. The priority here is 2 and 2. This is priority number 1 and this is priority number 2. Okay. So when we're solving this, here it is from time 0, from 0 to 3, idle. Then at time 3, you have a choice between P1 and P2. Look, let's do this as time 3, I'm sorry. So here P2 will be selected because it has the same priority. Now you tell me, what if they are actually the same priority? What if they are the same priority?